Number one, rewrite each of the following logarithms in exponential form. And the big idea of today is a logarithm we really need to think about in terms as the what power function. So there's a connection, there's that relationship between exponents and logarithms that define this inverse relationship. So if I have this equation here that log base 2 of 128 is 7, how can I express that in exponential form? Well, a logarithm is the what power function. This says 2 to what power gives me 128? Well, 2 to the 7th power is 128. 2 to the 7th power is 128. That's a true statement. Log base 3 of 1 is 0. Well, what this says is 3 to what power gives me 1? Well, 3 to the 0 power is 1. That's a true statement because any number to the 0 power is 1. And finally, 27 to what power is 9? The log base 27 of 9. 27 to what power is 9? Well, 27 to the 2/3 power is 9. If you remember your power over root, your how to deal with rational exponents, you'll see that that is also a true statement. So a logarithm is what we in the business use to describe the what power function. Evaluate each of the following expressions. So we actually want to figure out what's the value of log base 3 of 243. Well, what this says is 3 to what power gives you 243. 3 to what power gives me 243, and maybe after some guess and check, you get 5. So log base 3 of 243 is the number 5. Logarithms are exponents. It's saying what power, 3 to what power gives you 243. Log base 5 of 125, 5 to what power is 125? 5 to what power is 125? Well, 5 to the third is 125. Log base 2 of the cube root of 2. So 2 to what power gives me the cube root of 2? Well, hopefully remember a cube root is a 1/3 power. So 2 to the 1/3 gives me the cube root of 2. So log base 2 of the cube root of 2 is 1/3. We can't forget our rational exponent rules, or power over root. And finally, 4 to what power gives me 1 over 16? 4 to what power gives me 1 over 16? Well, 4 squared is 16, but because I want the reciprocal of that, I need a -2 power. 4 to the -2 is 1 over 16. So log base 4 of 1/16 is -2. That's what a logarithm is. A logarithm is the exponent in this relationship. It's the what power function. Explain why the log base b of 1 equals 0. So why does the log, regardless of what base it is, of 1 always equal 0? Well, logs are the what power function. B to the 0 always gives me 1. Logarithms equal exponents. So b to the 0 equals 1. This is always a true statement. This is equivalent. These two statements are equivalent. So if log base b of 1 equals 0, then b to the 0 equals 1. We know if b is bigger than 1, then b to the 0 power will equal 1, as we define the 0 power in our exponent unit. The 0 exponent last unit. Take a look back at your Unit 5 notes to make sure you understand why b to the 0 power is 1. Take a look back at Unit 5. I don't want to go into that now. But all you really had to do was to understand why log base b of 1 will always give you a 0. Whenever you have a 1 inside of a logarithm, it will always give you an output of 0, is because of this exponential equation here. We all know that b to the 0 equals 1. Explain why the domain, our favorite word domain, means our x values, our inputs. Why are my inputs of the log function positive real numbers? Well, why are my inputs positive real numbers? Well, maybe you can say log base b of x is the inverse of b to the x. So we know b to the x is always bigger than 0. B to the x is always bigger than 0. Our y values are always bigger than 0. So the range of b to the x is always bigger than 0. Because b to the x is the inverse, because log base b of x is the inverse of b to the x, the range becomes the domain. The range becomes the domain. B to no power gives you 0. B to no power will ever give you a negative number. So that's why we throw those out and we only allow positive real numbers to be the inputs. We only allow positive real numbers to be the inputs because we never have negative or we never get outputs that are negative or 0. Find the inverse of the given function. Well, we know our big idea is when we find inverse functions, we switch x and y. So this tells me that x, I'm not going to write in yellow because I can barely see that. X, I don't want to write in yellow. X, please don't, there we go, not yellow. X equals 4 to the y. Well, that's nice, but that y is trapped up in the exponent, so let's rewrite it in logarithmic form. Let's rewrite it in terms of a logarithm. Well, logs are the WhatPower function. Y equals log base 4 of x. 4 to what power gives me x? 4 to what power gives me x? Y. That's my inverse function. So f inverse of x is log base 4 of x. So the inverse of 4 to the x is log base 4 of x. There's that inverse relationship between logs and exponents. So when our variable is trapped in the exponent, we use logarithms. G of x equals 2 to the x minus 1 plus 3. Well, to find the inverse, we switch x and y. And we can all do that. We can all write x equals 2 to the y minus 1 plus 3. Okay, so let's subtract the 3 over. My variable is trapped in the exponent, so let's rewrite this in a logarithmic form. Let's rewrite this. My variable is trapped in the exponent, so we write it as a log. Well, I know I have log base 2. I know I have a base 2 log. What goes inside the logarithm is a big question. So, what goes inside the logarithm, the exponent or the answer? Well, logs equal exponents. So that means x minus 3 has to go in there. Check that this makes sense. 2 to what power gives you x minus 3? 2 to what power? 2 to what power gives you x minus 3? So the base is still the base of the logarithm. The exponent is what it's equal to. And then the answer, what it's equal to, goes inside the logarithm. And then we solve for y by adding 1 to both sides. So g inverse of x is the log base 2 of x minus 3 plus 1. So whenever your variable is trapped in the exponent like it was up here, we need to use logs. And the trickiest part is just taking this exponential equation and turning it into a logarithm by saying, that's my base, log base 2 is what I need. I know logs equal exponents, so I set it equal to my exponents, which means this answer part, x minus 3, has to go inside of the logarithm. And finally, h of x equals log base 5 of x. Well, to find the inverse, I'm going to switch x and y. So x equals log base 5 of y. Well, if logs are the inverse of exponents, exponents are the inverse of logarithms. So how am I going to deal with this? I don't like the way it looks. That y is trapped inside that logarithm, so let's rewrite it. 5 to what power gives me y? 5 to the x power gives me y. So h inverse of x is 5 to the x. Exponential functions are the inverse of logarithms. Logarithms are the inverse of exponential functions. Hopefully, this lesson gave you a good idea of what a logarithm is. The big idea is logs are the what power function. You need to understand logarithms are the what power function.